Hi everyone, so we're going to carry on this video series where we are doing the short questions from the higher level 2022 paper. This is question 6, that's where short questions are, and I'm on to the second one, question 6b, okay? That's probably, well, it actually is visible in front of you there in the title up the top, but it'll all be linked with the YouTube and on the website as well, so you should be able to find where you are. A quick reminder before I start getting into it. I have two reminders actually today. The best thing for you to do right now, if you're sitting there preparing for exams or revising, whatever you're doing, don't just watch me show you how to get the answer, because you'll think, oh yeah, that looks grand. I can follow those steps. I got it. The best thing to do is actually test yourself. So before you watch the video, before you see the answer, close everything, sit there with a pen and paper, pretend a little bit that you're inside in an exam center and you are trying to answer this. If you're really diligent, you might even set a timer for yourself, but I would say that's not just yet for most people. So try that. If you get stuck with just pen and paper, my next step would actually be to go to your books and your notes. See, can you get the information? You have your log tables that will be with you in the exam, so you can look away at those. They're quite handy for this one actually. And if that's still not working, play the video. And if you're being really you've got really good self-control, play one step in the video and go, okay, I have a hint now, can I do the next bit myself, and so on. Because the more that you do yourself, the more that you're actually learning. It's very easy to look at a sample answer or look at a video and say, oh yeah, cool, that makes sense, and think that you have it. But when you go to do it yourself, you might not get it just as well as that. Okay, that was the first thing. The second thing to point out, you might notice if you're following along these videos, they are much longer in terms of time than I would expect anyone to spend answering a short question in an exam. So for example, the last video, question 6a, it was like 18 minutes or something. That would be a really, really bad use of time in the exam. And the reason it's taking me such a long time is because I'm going into like a little bit the why and where I got my answer from, and going into all the details about algebra and everything else. But you might just answer it. They are 7 marks. I can talk more if people are interested about marks versus timing in the paper, but 7 marks is not something that you would spend 20 minutes on. It's very, very quick. You might spend 3 or 4 minutes on it, okay? So if you're in the kind of exam preparation mode, if you have any questions about that, send them in to me, and I'd be happy to help you out. So with that, I think we should start into this one. It's a quick one. It's one of those nifty ones that if you get it, it's super quick, but if you don't, you might end up in circles. So I'm just going to go through it. Like I said, if you want to try it out for yourself, absolutely do that first. Equally, if you think you have an answer, you think you've done the right steps, you don't need to sit through the whole video. Go off to the link on the website, check the sample answer or check the answers that come with your exam paper books. See, did you get it? And if you did, move on with your life. You're after figuring that type of question out, go on and do something else. All right. Okay. So it's asking you, it says, calculate how many electron volts are in a kilowatt hour. Okay, so how many, I'm just going to get my pen working for me here now, hopefully. Oh, sorry, I'm on the wrong thing. There we go. So how many electron volts are in kilowatt hours? It's a little bit of a skinny pen. Well, I should really say question mark there, but sorry, guys, I just like my marker to be a bit darker. Okay, how many? So this is the kind of trick or hint that you mightn't have gotten. You're doing a conversion, right? But instead of directly converting electron volts to kilowatt hours, I wouldn't know that off the top of my head, I'm going to turn both of them into joules because they're both energy. We've electron volts and we've kilowatt hours. They're both energies. Okay, and now this, you wouldn't have to write down that they're both energies in your answer, but that's just me explaining to you what I'm doing to get my answer. They're both energy. So let's put, and we all know that energy is joules. That's the SI unit for energy. And maybe we all should know. So I'm going to start with the electron volts. And for this guy, I just know it from lots and lots of practice, but it's in your log tables. It's on page 46 of the formula books. And even if you think you know it, but you feel nervous on the day and you want to quickly check it out, that's no harm either. So in every electron volt, and they're quite tiny, especially compared to kilowatt hours, you've got 1.602 by 10 to the minus 19, teeny tiny joules. Super. We've got our electron volts converted to joules, and now we need to convert our kilowatt hours to joules as well. And kilowatt hours, I'm going to break this down a little bit now. You might just know it, that's great. Kilowatt hours is a weird unit of energy. It's power and time. So if you remember the formula, that power, my handwriting isn't great, but hopefully you're following me anyway, is work over time. Then and you also might need to know that work, another word for work, is simply energy. Okay, it's just the ability to do stuff and move stuff and things like that. Okay, so power is work over time. And if I'm looking, I want to get kind of work on its own here, right? So I've got that will tell me that work, which also equals energy, is power times time. And that's exactly what a kilowatt hour is. Okay, so this is kind of an aside. I wouldn't be expecting anyone to write this in their exam, but if you found that it was helpful to write it down for yourself, that's no harm either. Okay, so work is power times time. That's actually on page 55. I should write up these for you. So that one was page 46, and this one was page 55. I would say I would not be relying. The last thing you want to spend half your exam flipping through the book trying to find what you want. So you either have a feeling roughly where they are in the book or have a few that you just know, okay? So because of this work is power over time, I want to get my kilowatt hours into joules. 1 kilowatt is, so 1 kilowatt, and so I'll just start with 1, is 1000 watts, that's power, that's what kW means. And you want to take your hours and put them into seconds, because joules are SI units. They're made up of watts and seconds. There's no kilo, no hours, no minutes, or any of that stuff. So you want to make it as nice and simple as you can. And in every hour, there's 60 minutes and there's 60 seconds. Okay, so all my brackets mean here are multiplying, just in case you're not familiar with that kind of way of writing it. So I'm going to have 1000 multiplied by 60 multiplied by 60. And if you do that out on your calculator, you're going to get you're going to get 3, 6. I'm going to watching my zeros really carefully here. 1, 2, 3. So I've got 3,600,000 joules. Okay, so a kilowatt hour is 3,006,000 joules. Up here, an electron volt is it's not even 1 joule, it's a tiny, tiny number of joules. 1.602 by 10 to the minus 19. My thing is getting a bit messy, so I'm going to come down a bit and just summarize. Don't worry if it's a bit messy in your exam. What I have now, so I'm not done yet because they've asked me to tell them to calculate how many electron volts are in a kilowatt hour. So even though I have both things in joules, I need to compare each now. If you didn't compare, you wouldn't be finished the question. So just to show what we have so far, we have, and probably wouldn't have to do this if my my screen was a bit bigger, so, or my writing was smaller, I guess. I've got 1 electron volt is 1.602 by 10 to the minus 19 joules. I took that straight out of my formula book. It's not something I calculated. And then 1 kilowatt hour, I took 1000 watts and turned my hours into seconds, is 3,600,000 joules. I've got 2 things in joules. That's great. That means I could compare them. Because if I didn't do that, I wouldn't be in the same kind of units. I couldn't compare in any meaningful way. So what we'll do, and you could use scientific notation for this as well if you wanted. Your calculator might have given it to you in something like this, and if these are the same, they're just written in scientific notation or not. So we 10 to the 6 joules, okay? It doesn't matter. It doesn't matter at all. You're going to get penalized either way, whichever one you feel happy with. So how many electron volts are in a kilowatt hour? I'm going to take my kilowatt hour number. Just going to use scientific notation just because I just had it there. And divide. Okay. Because I'm trying to work out how many of these little guys, these little electron volts, are in one of the big guys, the kilowatt hours. Okay. And I have an answer then 2.25 by 10 to the 25. And now, unusually in a physics exam, there is no unit going with this because this is just a number. It's just the amount of one thing that's in another thing. If you felt like I do, a bit incomplete, having no unit at the end, you could write kind of a bit of a sentence saying that I found 2.25 by 10 to the 25. That's a positive 25 electron volts. Sorry, electron volts in a kilowatt hour. Now you wouldn't have to write that. I just feel like it makes it a little bit clearer. So I've got 2.25 by 10 to the 25 electron volts in a kilowatt hour. And it makes sense that it's this massive number because I'm comparing things that are so totally different. Okay, so always do that little logical check at the end of your question. Does this make any sort of sense? So I have these tiny guys that are 10 to the minus 19. And I divided them into a massive 3,600,000 number. And that means that, of course, I'm going to have lots of them. Okay, so it takes an awful lot of electron volts to make up a kilowatt hour. They're just two that you wouldn't really see used much together when you're going through your course. And in this question, they're just checking, can you compare them? Did you think to put them both into joules? Did you remember to divide one into the other to get all your marks for this question? Okay. That's it for this one. I'm going to put it up along with a sample answer that looks a little bit tidier than this one and the marking scheme too, so you can judge how you might have gotten on with this when you did it, especially if you tested yourself out with it. And like always with the marking schemes, just because you got say 7 points for doing it this way this year, next year they might ask you for something different, or they might ask the exact same questions and the points might be distributed a bit differently across the question, if that makes sense. Any questions about the marking scheme, the sample answer, or this video, or anything else that has been bothering you, troubling you, niggling in your head about the physics course in general, please let me know. I'd love to hear from you, and thanks for watching. I hope you found it helpful.